Welcome back, quantitative analysis students. This is Mr. Marquetta, and today I would like to help you study chapter 1.6, which is applications of business and economics. Today we're going to explore the supply and demand, and we're also going to explore the profit, the revenue, and the cost. All right, in today's lecture, you'll see material for chapter 1.6 and 2.1 and 2.2. All three of those sections are in your week 2 module folder and submodules 2A and 2B. This PowerPoint, the next one, and also the video that I'm recording right now of us talking together will be found also in those folders in eCampus. I usually upload them shortly after class ends, so I'm almost certain they'll be up sometime tonight. We're going to start today's lecture by trying to go back to one of those old fundamentals that you're familiar with, probably from some of your other business classes, the concept of profit, revenue, and cost. The general ideas associated with them are such that if you look on the bottom, it says 3 important relationships. P of x equals R of x minus C of x is that the profit, which is represented by P of x, as you can see there, you can find that by subtracting the revenue minus the cost. Likewise, if you look in our vocabulary, you'll see they like to use those special function names, P of x, R of x, and C of x. Something about cost. Cost is usually expressed in 2 mathematical quantities, fixed costs and variable costs. The fixed costs are usually a constant, like a number, maybe it's $100,000 or something like that. A variable cost is based on how many items you're going to be making or selling or creating and such. The variable costs are, for example, if I say you're creating widgets for $3 each, it costs you $3 to make each widget. Well, then if you're making X widgets, well, then the variable cost is 3X. And if you have a fixed cost associated, it would be 3X plus whatever that number is, giving you the total cost function. So out of the 3 of them, profit, revenue, and cost, remember, like I said at the beginning, there's a beautiful relationship, profit equals revenue minus cost. But then there is another relationship that the cost is comprised of the fixed costs plus the variable costs. Remember, the fixed costs are constants, and the variable costs have the letter X in them, the variable X in them, because they are based on how many items you plan to create or sell. Likewise, in the terminology here, we have something important to talk about, the margin. The word margin is associated with the concept of slope or with the concept of average rate of change in terms of functions. The reason why when you studied y equals mx plus b, they chose the letter m for the slope was because m represents a margin. And all functions have, well, all linear functions are going to have a margin or slope. In the case of the profit function, the slope is called the marginal profit. In case of the revenue function, they call it the marginal revenue and the marginal cost for the cost function. Once again, break even happens at the specific time when the profit is 0. You can manipulate that first equation to be more along the lines of if you let 0 equal P of x, that first question in the 3 important relationships down there, if you add C of x to both sides, you'll notice that you have a new statement saying cost equals revenue, and that is also true. So you could look at break even in 2 different ways. Break even happens when you are at the place where there is 0 profit, meaning that you have not earned anymore, or you're still not in debt from your business, and you're at a perfect place of not plus and not minus. Or you could also interpret it as the time when all of the cost equals all of the revenue, i.e. all of the different things you had to pay out to make your business work is equal to the total amount of money you have brought into your cash register. And now, as you can see, once again, there's that beautiful balance where you have a break even. Okay, so once more in review, when it comes to the profit and the revenue and the cost, we have that first great relationship there. The second important relationship we have to be comfortable with is the idea of the cost function having a part that is a fixed cost and a part is having a variable cost. And you'll notice that the second bullet that's squeezed in there has a little statement about the revenue. One of the easiest ways to figure out the revenue is to just multiply the price by the number of units. Out of all of these different formulas, there is one underlying belief, and that belief is X equals the number of units. So if your revenue is $15 per unit, then your revenue function is simply 15X. It's that simple. So we have a lot of cute little connections that we could make associated with revenue, cost, and profit, including the idea of break even, and also the role of the slope or margin in each of those different functions is there as well. All right, so now we're going to use all those ideas and apply them to answering some word problems. And when we come up with equations, we can either do them the long way or we can use Desmos. For all intents here, I'm going to go ahead and use Desmos to demonstrate, again, how easy it is to solve equations using technology. Let's talk about an introductory case of cost, revenue, and profit. Here, example one, suppose a firm manufactures MP3 players and sells them for $50 each. The costs incurred in the production and sale of the MP3 players are $200,000 plus $10 for each player produced and sold. Write the profit function for the production of and sale of X players. So in something like this, there's the first thing that we want to talk about that's kind of important is not everybody knows what an MP3 player is. That is an old terminology that represents the idea of an iPod or a player that you can use to listen to your own favorite music and make playlists. That's what an MP3 player is. That aside, we talk about the cost here, and we talk about how much we're selling them for. The fact that we're selling them for $50 each, that is a hint that your revenue function is 50x. It says here the costs incurred in the production are $200,000 plus. That $200,000 is representing the fixed costs, plus 10 for each player produced. 10 for each player produced is the variable cost, that's 10x. So if you add those two things together, 200,000 plus 10x, you should get the cost function. Now, if you want to know what the profit function is, recall that the profit will be the revenue minus the cost. So here's the math associated with getting an answer to that. This is the answer. I'm going to write a little bit here so that we could see the concept. I would start by talking about how the revenue function is going to be 50x. And I think I'll make that white. There, we can see that clearly, right? And then I'm also going to talk about how the fixed costs are going to equal 200,000. Very good. And I'm also going to talk about how the variable costs are going to equal $10 times each item I'm creating, right? So that means the total cost function, which is the fixed costs plus the variable costs, is going to be 200,000 plus 10x. All right, good. So now I have a cost function. Oh, that was supposed to be cost. That came out a little bit funny. Let me rewrite that. There you go. That's what I meant to write. Typo. Sorry about that. And last but not least, let's try now to figure out what is the profit function. Well, the profit function, recall that formula is the profit function is the revenue function minus the cost function, like this. So let's plug them in. I did it again. This is what I'm trying to say. Okay, so now P of X is going to be R of X, which was 50x, minus the C of X. Now, remember, C of X is a binomial. So what I have to do is put it in parentheses so that I get it in there correctly. Take a look at the way I did that. There's an X missing there. Let me do that again. There we go. That's what I meant to say. So now what we would do is we would distribute, of course, this minus sign, because there is a 1 in here. Okay, so we're going to distribute the -1 to this and to this. When we do that, we have a new statement that says P of X is, of course, that 50x that's there. But now we're going to distribute -1, makes it minus 200,000 minus 10x, like this. And now I can combine these two things. This is called combining like terms. This one and this one combined together. 50x minus 10x is 40x, which is why your final answer looks like this. 40x minus 200,000. So that's how, my friends, you would go about figuring out the profit. Yeah, I didn't mean for that to come out. That's how I would have you figure out the profit function. It's based on the idea that you have the the revenue, you can figure that out to making 50x, and then the profit. And you also have to figure out the cost by adding those two things together. This is kind of a lot to extrapolate on based on a word problem. So that's what we were expecting for your solution. I hope that makes sense. And let's go on to the next example now. In the next example, we have marginal cost. Suppose that the cost in dollars is, as you see here, what is the marginal cost? I want you to take that sentence and compare it very closely to y equals mx plus b. One of your favorites, right? Very familiar with that. Can you see that m is clearly going to be $21.75? What is the marginal cost then? Well, the marginal cost obviously is $21.75. But what does it mean? Well, let's talk now about what it means. And I'm going to show you a funny statement here, and I want you to try to follow with me about it. The marginal cost is $21.75. Why? Because it's simply the slope of that function. The production of each additional unit will cost just that much more at any level of production. So let's pretend for a minute that you figured out the answer to when you make 100 units here. If you put 100 in there, it's 2175 plus 4890, whatever that number is, that's the total number of how much it makes to make 100 units. So I ask you now, if I wanted to make 101 units, what would it be? What would happen to that number? The answer is that number would only increase by $21.75. Like, in other words, if you put instead of 100 into X, you put 101 into X, it would only change the function by a specific value. That value is that margin of 21.75. So there's a general statement in business we like to use. The concept of the margin is the idea of how much it would cost, or how much profit you would make, or how much revenue you would earn if you made only one more item, or sold only one more item, or were able to make profit off of only one more item, like that. So look at the sentence here and let's try to remember this idea. The production of each additional unit will cost $21.75 more at any level of production, whether you've made 100, 1,000, or 100,000 of these widgets, or whatever you're making MP3 players in this situation. Okay, I hope that makes sense, friends. Our next concept has to do with breaking even, and breaking even, once again, is the concept that either your profit is equal to zero or that your revenue is equal to your cost. Here you're looking at another word problem that has all kinds of cryptic hints in it about how to construct the revenue function and the cost function based on the variable and fixed costs and so on, with the last task being solve when the profit equals zero, or solve when the revenue equals the cost. Let's investigate example number 3. It says the manufacturer sells a product for $10 per unit. I know already what the revenue function is. The revenue function is going to be, well, before I actually, hold on just a minute. Before I do that, let me put the revenue function in. The revenue function is going to be simply the price times X, right? So what we'll say then for the revenue function is R of X equals 10X. Great, there's your revenue function. Now, manufacturer's variable costs are $2.50 per unit. Okay, that's easy to write. The variable costs are $2.50 times X. There's your variable costs. And the total cost of 100 units is $1,450. Now, if the total cost of 100 units is $1,450, then you could say something like this. You could say C of 100 equals $1,450. All right. However, remember what the variable costs and the fixed costs are. If you talk about how the total costs of 100 units is 1,470, take a look now at how many units you can manufacture to make it even. With that information, look at the information we have here. We have the idea of 100 versus 1,450, and how does that play a role? Notice that they said that the total cost of 100 units is going to be 1,450. The variable costs are 250 per unit. Remember that the cost function, C of X, is the variable cost plus the fixed cost. Let's write that out. Now we know what the variable costs are already. It's $2.50, right? 250x plus the fixed costs. Now, I don't really know what the fixed costs are particularly, but one thing that I do know for sure is I know that the cost of 100 units is $14.50. I'm going to use that idea along with this idea together, this one and this one, to try to determine right now what the variable costs are. Once I know what the variable costs are, I could go back to the original cost function and assemble it using that idea. It will turn out looking like this when I'm through. Let me show you what I mean, okay? So if I know C of X is that, and I said no, C of 100 is this, then what I could do is I could write out a new equation here that says C of 100 equals 250 times 100 plus the fixed cost, which I don't know, looking like that. Now, I can use this idea of C of 100 equals 1450 to replace the left side. And by the way, I know what 2.50 times 100 is. It's 250. Can you see now that the fixed costs are actually 1250? Or is it 1200? Sorry, 1200. I'll subtract 250 from both sides. Like this, and I'll get 1200 equals fixed costs. Now, if I take 1200 equals the fixed costs and put that right here, then you'll see that this becomes C of X equals 2.50X plus 1200. Like that. Okay, and there's our answer, 2.50 plus X plus 1200. So looking at all of that math, guys, you have to go through all that and carefully pull apart all of those little details to figure out the cost function, and then of course to figure out the revenue function. Now that you have the cost function and the revenue function, if you can solve this equation, when does the C of X equal the R of X, right here, there we go. If you could solve that, then you got your answer. So what I'm going to do now is I'm going to take these two important equations and solve them by way of Desmos. That's easy to do. All you got to do is, sorry, not that one, this one. Open up Desmos and type in y equals 10x, and then type in y equals 250 plus 1200 and see where they cross. Let's go in now and try to do that. The first one was y equals 10x. If you recall, that was our revenue function. Remember, when you're doing things in Desmos, don't use C of x and other funny variables, try to use y and x. The other important function we used was the revenue function, which was y equals 250x plus 1200. Now, if we take those two and see where they cross, we could do that in Desmos by zooming out a little bit, like so. Keep zooming, right? It looks like they're going to cross up there and then kind of hover over and click. Look at what happened. X equals 160. So at the place of 160, the cost and revenue both will be exactly $1,600. You will have to pay $1,600 to make that many, and you will also earn $1,600 selling that many, both at the same time, i.e. the break-even moment is at 160 items, and that is your solution. You could, of course, have done that with our other techniques that we studied together for systems of equations, but why play around with that when you know you could go right in to Desmos and get your answer quick and easy. The next one is about market equilibrium. And when it comes to market equilibrium, really all you have to think about with market equilibrium is it is a simple system of equations, and all you have to do is just put them into Desmos and cross them. If you put them in with X and Y or with P and Q, they still work with no problem. I have never seen an issue with using P or Q into Desmos as well, so you could put them in. And when you do, what happens is, remember that P represents the price, and Q represents the quantity. In the world of economics, the Q is the variable. Some students argue that the X is alphabetically first, so it's the independent variable. The Y is after it, so it's the dependent variable. Here in the world of P and Q, Q is actually the independent variable. As you can see, P is the dependent variable, and that's not alphabetical. So don't let that throw you off. That's part of the reason why sometimes in economics and business books, you'll see the axes are backwards than what you're used to from your algebra books. Those are little nuances there that make economics so much fun and unique and different, but that is the application of economics at work there. Here we have a case of market equilibrium we're looking for in the case of these two functions, supply and demand. And all you gotta do is put them in Desmos and see where they cross. It's really a cinch. You don't have to think very hard at all about it. I recommend, friends, when you come to market equilibrium questions, go right to Desmos and put them in. Let's do an example where we're figuring this one out now together. Back to Desmos. In Desmos, to start again, I will close these boxes. I'll also click home to bring my axes back to home, and I'll type in the two formulas. The first formula was P equals minus 3Q plus 36. And then the next formula was P equals 4Q plus 1. And there's your answer, quick and painless. They cross right here. Obviously, the best quantity is 5, and then the best profit is 21. So in other words, if you were able to sell 5 items, you would be at a market equilibrium where the price would be $21 or $2,100 or 21 cents or whatever you're talking about. All right. Once in a blue moon, when you do market equilibrium, they'll throw in the concept of taxation. Taxation is actually not as complicated as you think. Whenever you see that there's a story where you're doing market equilibrium, you have a supply and demand, and then there is a bonus taxation, the way you deal with it is you tack it on and add it to the supplier. For example, in this one, it says the wholesaler is taxed $14 per unit. So what is the new equilibrium cost? It's really very simple. All you do is just add 14 bucks to the supply curve, and that's all you have to do for figuring out taxation. So okay, we need you guys to remember that when you're looking at a supply and demand curve, supply and demand curves, and you're adding a taxation, all you have to do is add the tax per unit straight on top of the supply curve, and then you have the new supply curve including tax, and you can answer the question. So the equilibrium point was Q equals 40 and P equals 250. The reason why they're telling you that is because if you actually solve these like it's a system using Desmos, you're going to get that as your answer. But now if the wholesaler taxed this much, then what is the new equilibrium point? Means change the supply curve to add in this 14. And then after you do that, you'll have a new supply curve and just do it all over again. So here's what it looks like when you do it all over again. You would graph the two of those in Desmos. I'm not going to drag you through it. We just did Desmos once before, but put them in that way and zoom around and you'll go and find your answer. In this particular case, the market equilibrium, the market equilibrium happens at the moment of 38 items where the price becomes 260. All right. So like I promised, friends, 1.6 was only about a half hour's worth of lecture. Those are the ideas associated with profit, revenue, and cost, and market equilibrium with the supply and demand curves for linear functions. In chapters 2.1 and 2.2, they do it for quadratic functions. So it's the same idea, and it's really a good thing to do today while we're in this economics mood with our lessons, and it does knock out tomorrow. We can take tomorrow off. We don't have to get together and meet for tomorrow's lesson. So let's focus now together, friends, on the next one. What I'd like to do, though, is I'd like to stop this video here and then start a new video for the next one. So we're going to do that, and I appreciate your close attention till chapter 1.6. We'll stop the video here and we'll start recording the next one in just a moment.